Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. New Horizons is an interplanetary space probe that was launched as a part of NASA's New Frontiers program. The spacecraft was launched to study the Pluto system and, in its secondary mission, the Kuiper belt, performing a flyby of Pluto and one or more other Kuiper belt objects. New Horizons was launched from Cape Canaveral, Florida on January 19, 2006, and after a very long journey, it arrived at Pluto on July 14, 2015. On October 22, 2015, New Horizons made a course correction for a January 1, 2019 flyby of Kuiper belt object 2014 MU69. Our guest today is Professor William B. McKinnon of the Department of Earth and Planetary Sciences at Washington University in St. Louis. Dr. McKinnon is a science team member on the New Horizons mission and serves as a deputy lead for the Geology and Geophysics imaging team. A recognized leader in his field, Dr. McKinnon's own research focuses on structure, origin, evolution, tectonics, and bombardment histories of outer planets, satellites, bodies in the Kuiper belt, as well as fundamentals of impact cratering throughout the solar system. Today we're going to talk about the space mission to Pluto and the little-known regions beyond. Dr. Bill McKinnon, thank you very much for coming with us and talking to us today. We're really thrilled to have you here to talk about this big mission, this Pluto mission. I mean, up until very recently, it was just like some blurry image out there. And now Pluto is, well, we have a much better idea of it, don't we?
Yeah, and I just want to say thanks for having me out, and it's always wonderful to be anywhere close to the world's largest ketchup bottle.
Well, you're very, very welcome.
Which kind of goes with the solar system's smallest planet, which is Pluto. And that's why we really couldn't see very much of it, because it's so far away, out beyond the orbit of Neptune most of the time. Even the Hubble Space Telescope could only give us kind of fuzzy little dot views of it.
Yeah.
So it's now become a real place.
Tell people in miles about how far it is from here. If we were to draw a straight line from here to Pluto, how far is it?
If you had to drive to Pluto, you'd have to go 3 billion miles, which would take a really long time.
Right.
Luckily, we built a small compact spacecraft, put it on the biggest rocket we have here in America, an Atlas V, and fired it off. So it was the fastest thing that ever left the surface of the Earth, and we were able to get to Pluto in under 10 years, which was our goal.
And how far did it actually travel? It was more than the 3 billion you just described.
Well, no, it was basically about 3 billion to Pluto, and now we're, as you mentioned in your introduction, we in fact are moving outbound from Pluto to another body, another billion miles.
Yeah, and you say that like, oh, you know,
well,
a billion here, a billion there.
Miles between friends.
But yeah, it does go, like I said, this is 2015, and it's not going to get there till January. Okay, it's almost 2016.
Yeah.
And by the time people see this, we'll be very close to 2016. So from New Year's Day 2016, another 3 years to New Year's Day 2019, and then it's there.
Yeah.
Now, is the funding all clear? I mean, we've got enough money to do this mission, or are you going to flip the switch and go like, hey, we're done? Well, the public's lost interest.
No, I don't. Well, number one, we're still getting data down from the New Horizons Pluto encounter because we're so far from the sun that it takes an hour just to send back a 1 megapixel image. And that's to our biggest radio dishes on the Earth. So we're going to keep sending data down all the way until August of next year.
Well, yeah, I mean, okay, so from the images that you first saw of Pluto, I mean, you have, you know, this pedigree in science. Okay. What did you learn pretty much immediately from these photos? Anything?
Well, we learned really about the incredible diversity and really beauty of this far off and modest world. And you might think, why would we bother to go? You know, people do ask me this. And it's It's a romantic place, of course. Children learn about Pluto, the little lone planet out there in deep space. But in reality, we found out that there's a whole new realm of the solar system beyond the planets that we all learn about. And we call this realm now the Kuiper belt. And this became the scientific reason to really explore. And so it's not, like you said, it's not just Pluto, it's Pluto and the Kuiper belt, and our first target was the biggest body in the Kuiper belt, Pluto, the king of the Kuiper belt, if you like, and its 5 known moons. But then the further goal is to find a secondary body, which we did just last year. And then, as you said, we have been firing our thrusters, and we've actually fired them a couple of times to change course slightly. And we're going to fire them a couple more times in a couple of weeks, and then we'll finally be on target for MU-69, this very small world out there in deep, deep space.
Why that one as opposed to, I mean, there are, I just discovered that there are a large number of little, you don't even call them, they're not called planetoids, there's another word.
We call them Kuiper belt bodies or Kuiper belt objects, or KBOs for short. And we know about 2,000 of them, but there are hundreds of thousands of them probably. We just can't see them with our telescopes because they're so far away. So, and this extended part of the mission, just getting back to an earlier question, was really, it's part of the game plan, but it's not part of the primary mission. So it's actually not funded. So we are retargeting to go to this new place, but our funding runs out in 2017, which is 2 years before we get there. And so we're going to have to write another proposal to NASA and basically jockey with all the other missions that are ongoing, like the Mars rovers, like who gets the limited amount of funds to continue going. Now, we think this should work, but we still have to write a good proposal, because if you write a bad proposal, NASA will not fund it.
So let me tell you what I think I've learned, and then you can correct me, Professor. All right. I'm going to start from the very beginning.
Okay.
As a youngster in school, I was taught that the solar system was the sun. We had 9 planets, and there were meteors that sometimes came through, and then there were some comets that sometimes came through. Sometimes these comets came through repetitively, and you could actually tell the timing, and that was our solar system, at least when I was young. But apparently, sometime starting in like the 1970s, this whole, actually starting in the 30s, but really in the 70s, and then by 92, all of a sudden it was discovered that there's actually like these snowflakes that are all around the outside of the solar system, and these little snowflakes are these Kuiper belt particles.
Yes, but they're bigger than snowflakes. They're like little worlds on their own. And in fact, Pluto is not alone. There are basically these dwarf or small planets, and we know about a good half dozen of them, and we're probably going to discover a lot more. But just like you say, like the architecture of the solar system has only slowly been revealed to us. You know, in ancient times, we knew about the planets out to Saturn. Telescopes then brought us Uranus, Neptune, and then ultimately Pluto in 1930. Clyde Tombaugh discovered it out in Arizona. But it really wasn't until the 1990s when we started to use CCDs on telescopes to really peer deeply into space.
Explain to people what you mean by that.
Oh,
CCDs.
okay. So everybody, in your cell phone, you have a CCD. That's what takes the pictures that you send to your friends. Right. Okay, it's an electronic imager as opposed to a film camera. So we used to take big photographic plates and bolt them onto the back of the telescope and expose them for hours to see into deep space. But now we use these electronic CCD imagers, some of which
they gather a lot more light than
they
film
have
does.
What we call quantum efficiencies approaching 1. So they get every photon of light makes a signal, so that you can, it's as good as you can get. So now the race is to just build bigger and bigger telescopes to gather more and more light.
Now, does that include the Hubble Space Telescope, which is in outer space and outside of the atmosphere?
Yeah, that one is actually not a very big telescope as things go, but it is, like you say, outside the atmosphere. So all of that distortion and any light that is blocked by molecules, like in the ultraviolet, that doesn't occur. So it is, in a way, our very sharpest view of the heavens. And that's actually the telescope that we use to discover the 4 small moons of Pluto. Along with the big one was discovered in ground-based plates taken.
So you knew that these moons were there of Pluto which Pluto being little and these things even littler, so you knew that before you even got there, that they were there.
Well, but we didn't know when we started the mission. We discovered while we were building the spacecraft, the first two of the small moons, which we named Nix and Hydra. And then while we were flying, even deeper images with Hubble, looking for any possible debris or hazard, which didn't show up, thankfully, found these two even smaller moons, Styx and Kerberos. So there's 4 little moons and 1 giant moon named Charon.
Right. Okay. So, so our whole vision of what the solar system is really changed, hasn't it?
Yeah. So just to return to that story. So you can actually think of the solar system as having not just worlds like the Earth or giant planets, but actually 3 zones. So the first zone is the terrestrial planets, Mercury, Venus, Earth, and Mars. You can count the moon in there if you want. And then there's the second zone, the giant planets, Jupiter, Saturn, Uranus, and Neptune, and all their moons. But beyond Neptune is the Kuiper belt, a vast reservoir of small to medium-sized worlds and some dwarf planets like Pluto that stretch out into space for, really, we're not even sure where it stops or if it stops. It could go all the way out to this vast cloud of comets we call the Oort Cloud.
Yeah, I was going to get to the Oort Cloud, which is
I guess that's the fourth
which
zone.
is the next layer.
Yeah.
That's but it's like we're talking about something between 1 and 3 light years from the sun.
Yeah,
that's pretty. I would have thought that by the time you get 1 to 3 light years from the sun, that you're now beyond the influence of the sun, and so how it could create almost like a sphere around our solar system, I'm not quite sure. Do you care to comment on that?
Well, all right. So as the sun travels through space of the galaxy, its gravity kind of holds this shell of comets, these Oort Cloud comets, at great distance, but they're very loosely bound. So that if there's another passing star, the Oort Cloud can get stripped, or comets can literally shower and rain in on the planets that, like the Earth.
Yes.
And so, but that's really far out in space. And out there, actually, even though the sun's gravity exists, the solar wind has stopped, and it's interstellar winds that or star winds that are flowing past these bodies.
Right.
The comets that we're most familiar with are like Halley, which, like you say, repeatedly return. Those bodies don't come from the Oort Cloud; they come ultimately from the Kuiper belt. And so,
I read about this. It's like, well, I wanted to be prepared to talk to you, and the ones that like Hale-Bopp, that was one that comes from way out there in the Oort Cloud, and will only be back every several thousand years.
Yeah, because their orbits are basically super long ellipses with the sun at one focus of the ellipse.
And is it actually? I forget. They actually come close to the sun, whip around, and then slingshot back out.
Yeah.
But they might not ever. They might just keep going.
Yeah, because
too.
they go so far away that they can get perturbed by the gravity of other stars again, and you don't know if and when they're ever going to come back.
I found it interesting back just a couple minutes ago when you were talking about the sun, and you were like moving along. You know, we Earthers tend to think of the sun as being like this stable. It's right there, and it's the center of our little universe. But in fact, it's not. It's traveling along at quite some speed, isn't it?
Well, yeah. I mean, in its own way. I mean, if you think of the Milky Way like a giant pinwheel galaxy, the whole thing's rotating. Stuff's rotating fast on the inside and rotating slowly on the outside. And the sun is just doing its little trajectory, and there are other stars that are nearby doing their little trajectories.
And these other stars that are nearby, these are the ones you're talking about that can't, because they infinitesimal amount of gravity that they exert, can move some of these Oort Cloud objects and perhaps Kuiper belt objects as well. Although Kuiper belt, it said Neptune somehow has an influence on it.
Luckily, the stars won't get close enough to the sun to perturb the Kuiper belt, because if they would perturb the inner planets too, which is what we live on. So the Kuiper belt is really kind of bound more tightly to the sun. It's just outside of Neptune, that kind of thing. So, when we fly to Pluto, we find out that instead of being just being a cratered ice ball, it's actually this very dynamic world with all sorts of things happening on it. It has an atmosphere, it has a big moon, it's geologically alive. And so it's fascinating to us. And it kind of says basically that out there in space, there's kind of no limit to the interest and diversity and beauty of worlds. And it's It's just up to us to explore.
My wife and I, in 2006, were traveling, I can't remember if we were in Canada or in the Western United States, and all of a sudden we picked up this copy of USA Today, and to our shock, Pluto, the ninth planet, the one I've learned was a ninth planet, although it doesn't really orbit in the same way as all the others, that it had been taken away from us. And it was now a dwarf planet, and we were just so sad for Pluto that they had taken away its status. What was that all about?
It's a sad day for astronomy. That's all I can tell you.
So what is all that? I mean, what is the difference between Pluto, the planet, and Pluto, the dwarf planet, or Pluto, the Kuiper belt object?
There's no difference. Pluto hasn't changed, and it doesn't care what we call it. But
why do we, or your
astronomers,
colleagues changed the definition?
My colleagues
there?
in the International Astronomical Union, and I'm a member of this, had a debate, and a small number of them voted to change the classification. So some people think it's a demotion. I think of it more as a reclassification, that Pluto was sort of not like all the other planets, and we were discovering these new bodies in the Kuiper belt that were Pluto-like. And so there's a new classification called dwarf planet, and it fundamentally just means small planet, and that's exactly what Pluto is. And if anybody wants to argue about this, it's really within the IAU, they have like a little sort of, footnote saying dwarf planets are not planets, but that's kind of silly. It's like saying dwarf trees aren't trees, or dwarf galaxies aren't galaxies, or dwarf stars aren't stars. So that's all silly. But it just says that there's kind of a whole hierarchy of planets. There are different kinds of planets. So
there's most of the planets. 8 of the planets are on, what's it called, the ecliptic? We're all basically on a plane.
They're on a
together.
plane, that's right.
And they orbit pretty much in sync on this one plane.
Yeah, that's right. That's right.
I don't know why it does that, but it does. Okay. And then there's Pluto, which is tilted. And it doesn't. So that's a big difference between why is it that most of the planets are on the ecliptic and then these Kuiper belt objects are canted? Yeah,
so you think of it this way. The original solar system formed from a collapsed disk of material. This goes back to basically 18th and 17th century physical thinking. So, and they're born that way. They accumulate from smaller bodies, and they grow, and they make this orbiting disk of bodies. The smaller worlds that are perturbed by gravity, like the asteroids between Mars and Jupiter, and the Kuiper belt, which is kind of like an asteroid belt on steroids that exists beyond Neptune, they all are either leftovers or their orbits got scattered, and that allows them to be tilted this way and that. In fact, if you look at the Kuiper belt, the distribution and the kind of orbits they have, like Pluto, like you say, has this tilted orbit. It's very eccentric. Sometimes it's closer to the sun than Neptune. This is actually a signature of how the solar system evolved. And this is actually the neatest thing. The neatest thing about Pluto, honestly, is not that it's beautiful geologically, which is what I study, but it was the key to understanding what happened in the early solar system. It and the Kuiper belt tell us that the giant planets didn't form where they are. They actually formed closer to the sun. And by gravitationally interacting with a lot of small bodies, their orbits expanded, and the Kuiper belt was populated about 4 billion years ago and built by the whole solar system changing radically over.
Yeah, I was surprised to read that Jupiter is actually closer into the sun than it was, and Saturn, Neptune, and Uranus are further away from where they were formed.
Jupiter's moved a little bit because it's the biggest planet, right? So it's kind of like a giant anchor in the solar system. It's hard for it to move. But it did move in, and the other ones moved way out and pushed all the small bodies out. And that's what the Kuiper belt tells us.
I see.
And that is our present best explanation, actually, because when things are moving out into the Kuiper belt, they're also being flung all over dynamically. And that's the source of all the craters, the things that hit the moon, that make the cratered surface of the moon, and the cratered southern hemisphere of Mars, and the cratered surface of Mercury, and presumably hit the Earth as well, although our geology is so active.
That's where they all come from.
That's where they came from, this reorganization of the solar system back around 4 billion years ago.
And is that process slowed to a stop, or is
Thank
it?
goodness, yes.
Otherwise,
We would
so
still be
all
getting
these
whacked.
movies about the Earth is about to be hit by some planet-killing meteor. That's more science fiction than, although it is possible, but more science fiction than reality.
Those are now rare events where asteroids mostly leak from the asteroid belt due to the gravitational perturbations of Jupiter and wend their way to the Earth. And the last, of course, big event like that you've heard of is the one that terminated the reign of the dinosaurs.
65 million years ago,
so,
hit in the Gulf of Mexico.
And we have telescopes now, and we track near-Earth asteroids because there's a swarm of these gals, that are intersecting the orbit of the Earth, and small ones do hit the Earth, like the one that hit Russia, a couple of years ago. It was in the news.
Or back in the early 1900s.
Well, that was the one, the Tunguska Event. But the thing that flew over the Siberian,
yes.
Western Siberian city, and made the big fireball and explosion. Lots of great YouTube videos.
Yes.
So we know where all the big ones are. We are not in any danger of any dinosaur-killing asteroid strikes in our lifetimes, or even really for hundreds of years in the future.
Well, you've just made some movie producers really sad that they're not going to actually have some footage of that. Now, there are many dual sun systems or dual star systems. What is it that's different about them? If you added up Jupiter, Saturn, Uranus, Neptune, and had squished them together, would you have had a binary system here in our solar system or not?
No. Jupiter's only about 1/10 of 1% of the mass of the sun, and even if you added all the other planets, it wouldn't get much bigger. Not enough to start thermonuclear fusion and light up as a star.
Right.
So other places, though, most stars don't form by themselves. They are in binaries or even in triples or quadruples.
Now, would they have planets, or do we not know that?
They can, and in fact, we have discovered, as you read in the news, lots of people are discovering new planets around other stars. We know many more planets around other stars than there are planets in our own solar system at this point. And there are planets around close binaries, and there are wide binaries where I believe each one, or at least one, has some planets. So you can form planets in different ways. Yeah,
their own movement.
As long as you get far enough away, and the gravity of the other star won't mess it up.
That's interesting.
Now, that's, of course, not my field, and so I can't speak expertly to it and tell you all the great details.
Right. But, look who you're dealing with.
No. Space is full of stuff, and I can't pay attention to everything.
Right. So let's come all the way back to the beginning, New Horizons.
Okay.
All right. So it was worth the money, in your opinion, that we spent on that. How much are we talking about?
We're talking soup to nuts. When we're done in 2017 with our official mission, it'll be about $720 million.
That's it.
Yeah,
it's
almost
in the days when we're spending billions of dollars on nothing, $720 million for all of this new knowledge.
Yeah, I think the knowledge is really worth it. And also, if you divide it over, we started the mission in 2001 because we had to build the machine and then launch it. So you divide that by the year and then by the number of people in the U.S. It's like it's pennies every year. People just drop it on the ground and don't even bother to pick it up.
And how much is you said you're going to have to write an additional grant to NASA. How much do you need to?
I actually don't. I don't have that number. We haven't worked that out. But it's got to be much less because we're already on our way, and we just have to basically pay the people to take the data. We have to actually, in a sense,
sit at the panels,
and tell the Deep Space Net to receive the data and send it to us, and some salaries. It's going to be very modest.
So it sounds like a couple $1 million.
Well, a little more than that, I think, to keep the number of people. You think of people's salaries and how many person years. Yeah, and it's actually, we're not firing the money off into space in a rocket.
Right. It actually gets spent
it's all right
here, and they go to the grocery store.
Exactly,
they go to Walmart. They actually do spend the money here, unless we're buying parts from overseas.
Yeah, we're not buying any parts. There are no parts involved. No rocket fuel. I mean, you think about it. The rocket gets burned up.
It's already on its way.
Yeah.
Okay. So what's next after this? And by the way, we're down to less than 5 minutes here.
Okay.
So what's next from your perspective for learning new stuff beyond your MU-69?
You mean for Pluto or just in space in general?
In space in general, what was it, New Frontiers?
New Frontiers,
yeah.
Well, New Frontiers, our mission actually proved a kind of concept that we could actually design our own spacecraft. NASA didn't design it. You know, it was basically a principal investigator-led mission from the Applied Physics Lab in Maryland. So there actually are a couple of these New Frontiers missions. One isn't going to orbit Jupiter. It's going to get there mysteriously enough on July 4th.
It's on its way now.
Yeah, it's on its way. It's almost there. It's actually solar powered, and we're building right now. We've just about finished another mission that will go to an asteroid that's passing near the Earth and grab a piece of it and bring it back to the Earth for a study. But from my point of view, what would be really neat is to go back into the outer solar system and study some of the worlds that have a potential for maybe some sort of primitive life. And the one that we're just starting now, and I hope it will ultimately get there, is a mission to Europa,
which is a moon of Jupiter.
And it's an ice-covered moon. It's bright and reflective, but underneath that ice shell is an ocean of salty water. And of course, we would like to know if there's any possibility of even the most primitive, simple form of life in that water. Because we know the chemicals are there, we know the energy source is there, but we don't know the answer.
Well, there have been numerous movies in which Earth was seeded by extraterrestrial life.
Yeah.
Is there any thought process in the scientific community about we become the seeders? So in other words, we throw something into the ocean there on this moon?
I don't think we've actually talked about that yet. We've certainly talked about, obviously sending people to Mars. We've probably already polluted Mars with germs in some way, but they probably didn't get much of a purchase there. But ultimately,
not at 100 below zero.
No, and the radiation and all the rest of it, it's very, very cold. So but you can imagine in the future, this century or next, maybe some sort of small colony on Mars. But actually putting life into the ocean, I think we want to study first the ocean on Europa. What is there? In fact, we have all of these fancy rules about not contaminating worlds. So as an example, the Galileo orbiter, which studied Jupiter in the 1990s by orbiting, it wasn't allowed to just die in place on the off chance it might collide with the surface of Europa, which itself is completely inhospitable to life. But it was in fact sent into the atmosphere of Jupiter to make sure it all burned up, and that was the end of it.
Can you quickly describe what it's like to live on Mars right now today?
It's kind of like living in the high desert of Chile. It's cold, it's very dry, there's intense ultraviolet radiation, the ground is very crunchy.
When you say cold, what's the high like?
Oh, well, it depends on where you are. I mean, it can get up to actually above freezing. But at night, it'll be like Antarctica. It'll be like minus 100 degrees centigrade.
Right. So I mean, they're talking about sending humans up there on a one-way trip to live in a colony in about 30 seconds. What's your opinion of that?
I think that's more of a publicity stunt. But if you want to get a sense of what might actually happen, go see the movie The Martian.
Oh.
I think
Okay.
they tried to make a reasonable extrapolation about what actual spacecraft, what kind of artificial gravity would be needed for the long trip, and what kind of supplies would be necessary.
I'll have to do that. Thank you very much for being with us today. Certainly appreciate having you here.
All right, wonderful to be here too. Thanks.
And I've been speaking with Dr. William McKinnon of of Washington University in St. Louis. He was what was your title? I forget what we said here.
I was one of the deputy leads on the
Yeah.
Geology and Geophysics and Imaging team.
Right.
We kind of divided ourselves into 4 teams.
And you heard about that we did go to Pluto, so hopefully you heard that. Anyways, we're going to upload this whole story to YouTube, so show it to your friends. Thanks. See you next time. Bye.